Hello, everyone. Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. This is your teacher Kent. And today we're gonna talk about electric circuits. Now, I know in the lesson we're supposed to talk about another topic, but I reviewed it and found out that no, we're already finished with that topic. So today we're going to talk about electric circuits. Are you ready? Let's start. Let me just open my PowerPoint so we can finally start our lesson. Okay, here it is. Let me just share my screen, and there. Fun facts about electric circuits and electricity. Now, before we go to the fun facts, we need to have a short review on what we call the electric circuits. So let me just find it here. Okay, let me just share it with you guys and let's start. Simple electric circuit. First question before we continue is, what is electricity? It's energy moving from one place to the other. That is the basic understanding of electricity. It provides most of the energy to run the whole world. Almost all parts of the world use electricity. You use it for your Android phones or your Apple iPhones. You use it to store our food with the refrigerators. We also use it to run our cars or our vehicles. Now, the first question is, who discovered electricity? It's this guy. He is Michael Faraday. He did not finish school, but he invented the rubber balloon, and he used the balloons to have experiments on electromagnetism. Now, what is an electric circuit? An electric circuit is basically a complete pathway for energy to flow. Imagine your house, and your house has a driveway for your car, and your car goes out and you can go to Supalak school through the driveway. That is an example of an electric circuit. It's a driveway. It's a road for energy to travel. What does it look like? It looks something like this. It has four major components, and it has these ones. These are called the wires. Now, the wires have bronze inside because bronze can transfer electricity very far, but it is covered by a lot of plastic because plastic stops electricity. This helps us travel or move electricity but not touch the electric parts ourselves. The next part is the battery. Every single electric circuit needs a source of electricity. In this case, it is called a battery. Then we have the light bulb. The light bulb or the things that need the electricity in order to function. And then the switch. We can't just let electricity turn on all the time. We need a switch so that we can turn it off if we're not using it. Because using a lot of electricity, even if we don't need it, is actually a waste of time. Now, how do they combine? It looks a little something like this. See that? The wire goes and touches all of the components because the wire is where the electricity travels. And electricity travels through a switch. The switch can turn off or turn on the electric current so that when you don't need anything, you can just turn it off. And the light bulbs are the ones that use the electricity. This is a diagram of a simple electric circuit, just like that. Basic electric circuit. There's a battery, there's a positive and negative charge. Or I forgot to mention, a battery has two poles, the positive and the negative, because those two needs to meet in order for electricity to happen. The switch can turn it on and turn it off, and the light bulb will show if there is electricity or not. Now, now we got a simple review. Let's start with our main topic. We're gonna talk about the fun facts about electric circuits and electricity. Look at that guy. Electrocuted or shocked? Now, sometimes people will say, I got electrocuted, or some will say, I got shocked. Which is correct? Let's find out. The word electrocute is a combination of the words electro and execute, meaning you were killed by electricity. So if you didn't die, you were not electrocuted. You are only shocked. Okay? You remember that. Next time you're playing with something, you feel an electric current pass you, you say you were shocked. When I go to Tesco, sometimes I don't know why, but when I touch the cart, it shocks me. It doesn't electrocute me because it means electrocute means you're dead because of electricity. So you are shocked. Okay? Next fun fact. Proper discovery. Electricity was discovered by the ancient Greeks who demonstrated that rubbing fur against amber led to a mutual attraction between the two materials. However, it was not until the 18th century that Alessandro Volta produced a steady electrical current. Learning about simple circuits is essential in high school education and can also be great fun. Now, we said that Michael Faraday discovered electricity, and that's correct because Michael Faraday made the simple roots of what is electricity, how it behaves. In order for us to use something, we must know how the thing can be used. But the ones who knew about electricity, documented it first, are the ancient Greeks. They rub fur. Fur is the coat, the hair of the animals. They rub it and they touch it against amber, which is a kind of a stone. And then there is an attraction. That is called a static to kinetic energy. Even if they discovered this, they still didn't know what that meant. They just thought, oh, it's just another thing that's weird because they don't know how to use it yet. Michael Faraday tried and experimented using rubber balloons to learn more about electricity. He found out how it works, and Alessandro Volta produced a steady electrical current, meaning Volta was the one who discovered that electricity can be used by people. Do you understand now? Let's go to the next fun fact. Oh, the electricity from the sky, otherwise known as lightning. The speed of electricity. Electricity travels at the speed of light, about 3,000 kilometers per second. Oh, that's very fast. You should know that Bangkok to Suphanburi is less than 500 kilometers. It's about 200 or 300 kilometers. If you can run at the speed of electricity, when you run from Bangkok, when you run from Suphanburi, you might end up for just 1 second. When you run for just 1 second, you might end up circling the world and go to another country. That is how fast electricity is. It's 300,000 kilometers per second. And always remember, electricity is is the no, lightning is the electricity, the light, and thunder is the sound. Light always shows itself first before the sound. Next, we have the first electrical appliances. Now that people before found out they can use electricity, they tried to make things that uses electricity. And in this case, the first four common domestic items to be powered by electricity were the sewing machine, the fan, the kettle, and the toaster. Now, the sewing machine, if you haven't seen it, it's how people before used to make clothes. Even until now, there's now automatic sewing machines. And in the picture above, that is a picture of an old electric fan. It's all metal because it allows more electricity to move. However, people decided we can use plastic so that we will not be shocked because metal attracts electricity. Another one picture is a vintage. Vintage means something that is old. A vintage toaster. Y- the Thai people like to burn toast. Like to burn sliced bread to make in the toast. The Americans do too. So they made an electric toaster. Next one, idle current. Appliances also use electricity when they're switched off. The average desktop computer idles at 800 watts, while the average laptop idles at 20 watts. A Sony PlayStation 3 uses about 200 watts when it's active and when it's idle. So, from this point, you should remember idle current when you're not using your laptops or anything else, you should plug it off or disconnect the charger because even if it's not using it, even if it's off, as long as the electric current is connected, it still uses electricity. When I use my laptop at home, when I am finished, I take off the charger. It's okay if you leave the plug on as long as it's not connected to anything. Even if your laptop is turned off but it is still connected to the electricity, it will get power. So in order to save power and in order to save money, you can take pull off the plug or you can take off the charger. It's the same with a computer and a PlayStation and an Xbox if you have Xbox. That's called idle current. Next, the evolution of appliances. As an example of how much more efficient modern appliances are, a fridge from the mid 80s, 30 years ago, used four times as much electricity as a modern one, about 1,400 kilowatt a year compared to 350 kilowatts per hour. Now, what does this mean? It means that people have understood the importance of electricity. We understood how much it moves, so much that we don't need to make electricity move a lot more than what we did before. Before, people thought that we need this much electricity in order to make ice. 1,400 kilowatts per hour. That's a whole lot of kilowatt. But now, even with the brand new, the refrigerators that are bigger than the previous refrigerators, they only use 350 kilowatt hours per hour. That means that we evolved our appliances because we understand more what electricity can do. Next one is this one, this animal. What animal is this, class? The type of animal that can create electricity. Did you say an eel? Because you would be correct. This is an eel. Animal currents. In some species of fish native to the Amazon River, certain muscles cells have evolved over millions of years into cells called electrolytes, which they use for echolocation. That is to detect obstacles and other animals in the dark. Not just the eels, but other fish. They evolved especially for the fish under the sea, under thousands of kilometers in the sea, where the sun cannot go there anymore because it's already absorbed by everything else. It's pure darkness. but they use echolocation. They use some sort of electricity in order for them to see, because when animals cannot have sunlight, they cannot see. So the animals, they evolved. They use echolocation. It's like they have eyes, but through the use of electricity. Next is cheese electricity. In Albertville, France, they make electricity from cheese. Wow, they got cheese. They got electricity from cheese. Since whey isn't needed to make Beaufort cheese, bacteria is added to the whey, turning it into biogas. This gas is then fed through an engine which heats water to generate electricity. That's amazing. They made cheese, then the cheese they made may give them electricity. What is this? This is an electric chair punishment. Oh, sorry. Electric chair punishment. Electricity was introduced to Ethiopia in 1896 after Emperor Menelik II ordered two newly invented electric chairs as a form of humane capital punishment and realized they were useless in his country without electricity. Oh, this is an electric chair. Some countries, for the people that are so bad, that what they did is unforgivable, they are killed using electricity because it is fast and it only hurts a little bit. This is called the old electrical chair. Finally, we have Gecko Man. You may have watched a gecko climb that looks to be a smooth surface. This ability is due to the electrostatic forces on the gecko's toe pads. The difference in charge between its feet and the surface help it stick to the wall. Oh, even geckos that climb, they use a sort of electricity. They use negative and positive charges so that they can climb walls. That's very amazing. That's the end. I hope you learned something new today, and I wish to see you soon. Goodbye.